Okay, good eve. Next is uh, multi-pressure evaporator, individual expansion, uh, with heat exchanger and back pressure valve refrigeration system. So this would be the next assignment. Okay, this one. This is our title. Multi-pressure evaporators, individual expansion device, single compressor with back pressure valve and heat exchanger. Okay, so this is the block diagram. Okay, you are going to use ammonia in all your assignment. Okay, this time we are going to connect a heat exchanger in the system. This one. Okay, so your evaporator A, evaporator B, and evaporator C. Let us consider 40 degrees Celsius. This time I set your evaporator A equal to 5. Then this is negative 2. And then we have, let's say, negative 10 degrees Celsius. With tonnage for evaporator A, let us consider 60 tons, 50 tons, and for evaporator C, we have 70 tons. So we have different pressures in your evaporator. Again, to reduce the pressure correspond to 5 and negative 2, both of them are higher compared with the pressure for negative 10 using ammonia. Okay, so we need to connect back pressure valve in this two higher pressure evaporator. Consider this as your back pressure valve 1 and back pressure valve 2. You set these two, back pressure valve 1 and 2, set it equal to the pressure correspond to negative 10. Okay, and then fast to point X, then it will not directly go to the compressor. Instead, it will pass into the heat exchanger so that there will be an exchange of heat from there, changing condition of your refrigerant after X. It will convert that into superheated vapor, low pressure, low temperature before it is compressed at point 1. Okay, and then point 2. So there are two mass and energy balance in the system. One is at point X, the other one is in the heat exchanger. Let us consider subcooling temperature equal to 30 degrees Celsius. Okay. Again, the back pressure 2, is used to reduce the pressure of 5 and negative 2. You set this back pressure valve 1 and back pressure valve 2. Set it equal to the pressure correspond to negative 10 at evaporator C in such a way that After it will pass to back pressure valve bar and to all of the pressure from this line, and this line, all of them are equal to the pressure correspond to -10. And then we'll pass to point X for the first mass and energy balance. At this point, we already have mass total there. Considering your mass A along evaporator A, mass B on evaporator B, and mass C, evaporator C. We later on pass to this point X at the same pressure correspond to the pressure correspond to -10. Okay. Again, you can easily determine the masses since we already have the given tonnage in the system. The usual way, our mass A is equal to 3.5167 kilojoules second ton. Then you have there the R's. Let us consider first the numbering. 1, 2, then this is 3. This 1 is not anymore saturated. Instead, it is in the superheated region. Point 2 is at superheated vapor, high pressure, high temperature. You reject heat into your condenser so that your superheated region transform into saturated liquid. And then this saturated liquid is subcooled further to 0.4. This one, this is your 0.4. All of these are 4. 4, 4. From 40, it is subcooled to 30 degrees. Okay? And then, after expansion device 1, it is considered 0.5 wet mixture. Then 4, pass to the second expansion device. This is now your 0.6. And then the third expansion device 4 to 7. All of them are wet mixture. Then this, after the evaporator, they are considered saturated. We have there 8, 9, 10. Okay, 8, 9, 10. All of these 8, 9, 10, they are saturated vapor. At point X, there is a balance in there. Therefore, we have there point 10. You pass it again to the heat exchanger. This side, the high pressure side, gives off heat. This is considered closed system because they are not directly in contact. No? The refrigerant are not in direct contact because this side is high pressure, the other side is low pressure. So the high pressure side will be the one who gives off heat and absorbed by the low pressure side before it will enter to your compressor. So this is a closed system. Okay. So at point 1 or at point 10, it will pass to the heat exchanger, and then after the refrigerant, mass of refrigerant, the total mass of refrigerant exchange heat, then there will be a change of condition at point 1. We don't know yet the exact value of enthalpy 10 and the exact value of point 1 as well as the location. We are First, to determine this by computation, first by energy balance, mass and energy balance in point X or at point X, and at heat exchanger, in your heat exchanger, you perform only energy balance. You consider only the enthalpy. This one, you consider both mass and the enthalpy because it is an open system. Point X is actually a cylinder. It is, maybe I can consider this as the uh, accumulator, accumulator of the low side. Both the masses and the enthalpy mixed together. So this point X is an open system. Whereas in your heat exchanger, it is, as I've said, it is closed system because there are two pressure involved. The high pressure coming from the condenser and the low pressure coming from the evaporators. So high pressure and low pressure will not uh, in direct contact, or they were not able to mix with each other because high and low are they have different pressure. Of course, if you have a direct contact of high pressure and low pressure, only the high pressure will come in. The low pressure will not able to go inside the heat exchanger because it is low pressure, obviously. So it only gives off heat as defined in thermodynamics. It's allow only the transfer of heat, but there is no mixing of medium. So it allows only exchange of heat in your heat exchanger. Okay, the high side will be the one, yeah, giving off heat and absorbed by the low side condition, low side pressure condition, and heat is always transferred from hotter region to colder region. The low pressure condition is cold, and the high pressure condition is obviously higher temperature. So they are the one. This side will be responsible for the exchange. It supply heat from the low pressure side. The low pressure side will only absorb the heat coming from the high pressure side. So again, to balancing at point X and your heat exchanger. Okay. Uh, your mass A is equal to 3.5167 multiplied by the 60 tons over REA. And REA is defined as the change of difference of enthalpy into entrance against the entrance and the exit point of an evaporator. So 8 is greater than 5. So H8 minus H5. Mass B is 3.5167 kilojoules second ton. We have 50 tons over REB. Your REB is the difference of enthalpy 9 minus 6, H9, H6. Then mass C 3.5167 kilojoules second ton. 70 tons. REC. REC is 10 minus 7. Okay.